Hey, and welcome to today's flip lesson, in which we are going to pick up from where we left off. First of all, here are the answers to our introduction to logarithms. We really focused on the properties. You may want to pause the video so you can check your answers here. But I want to point out for a problem that I thought was pretty tricky, and I wanted to make sure you saw the small subtleties, and that was number 18. Number 18, did you see this? Did you see that these two bases are different? And so what this does is it prohibits you from going straight to the duh property, and you have to kind of think about this differently. And my suggestion to you is maybe there's a way you could look at this. Maybe you could think about this and convert log base 3 of 27 into just a number. Maybe you can think, what do I know about log base 3 of 27? I know it's got to equal something. Maybe I'll call that something an unknown empty box. And if you can't think logarithmically, perhaps you could change this to a form that will better help you find the answer. So if you missed number 18 or you struggled with it, it is worth looking at again, because it turns out you can't use the duh property. So today our focus is on how we solve equations that have logarithms in them. And if you want to follow along in your book, or you want to get some extra practice, or just get some extra things to follow, some extra examples, it is Chapter 3, Section 4. So let's start out today with some, what I'll call fairly easy problems to investigate with logarithms. So let's do this. Here's problem number 1. You know what? Let me perhaps hide this. We'll just come down here and we'll just look only at one. We won't let the other problems be unveiled just yet. So if you're solving this, your first thing might be, oh, actually, look, I have my logarithm to one side. I'm not thinking logarithmically, so perhaps we'll think exponentially. Now remember, the way this is written, ln, this is the natural log, this is the log base e. So if we want, we can convert it from logarithmic form into exponential form. My base is e, my exponent is negative 1/2, and that equals some number. And so what I can do is I can go right over here into my calculator here, and I can say, well, let's see, e to the negative 1/2 power is equal to that. And I'll round it to the nearest 1,000th place. It's that simple. Now, let me remind you, for all these problems, we have the possibility of getting false roots. Through no fault of our own, we get a value that you cannot have. And in this case, we want to make sure that the base is always a positive, not 0, not 1, but a positive number. And we want to make sure that this number in here is always a strictly positive number. And that's okay. This number checks out. It's fine. Let's try a second example. Well, here's a second example right here. You're looking at this, and at first you might get a little panicky, saying, oh, my heavens, we have logarithms all over the place. But look a little closer. I think that this problem right here is screaming out, duh. If log base 4 of this equals log base 4 of that, then duh, this has to equal that. And with a little bit of algebra, we can get x equals 1. And again, we want to check our answers. We want to put a 1 back in here for x and make sure that these numbers inside the logarithm check out. They can't be negative. They can't be 0. And sure enough, 3 times 1 plus 2, 5. 6 minus 1, 5. Everything's okay. These problems aren't super bad. See, they're kind of some easy problems. Let's take a look at one last problem here. Okay, so I noticed that all 3 of these are log base 3, but we're not ready for a duh. A duh is a single logarithm equals a single logarithm. And on the left side, this is not a single logarithm, but I can make it one using the quotient property. So again, every time I subtract separate logarithms, I'm dividing. And so now that we have a single logarithm equals a single logarithm, both are base 3, I can use a duh. And again, pause the video, do the math, make sure that you can get the answer. Welcome back. Hopefully you did use a duh, and you ended up down here getting x equals 1, and you took that 1 and plugged it back into all 3 of these scenarios and saw that all the numbers worked out and were fine. So those are problems I thought were pretty easy. Now in this section, let's look at some problems that are, okay. Maybe not easy, maybe they're just okay. Here's the first one. And in this problem, you might think that this is kind of a very straightforward problem, but I do want to highlight that we have this number here, this 8. And we have to make a decision about what we want to do with that 8. Before I convert this into exponential notation, that 8 can't be there. And I have 2 choices. I can either take this 8 and use the product property and put it right here as my exponent, or if I prefer not to do that, I can actually just go ahead and divide both sides by 8. And I think that's the one I'm going to do, just because 27 to the 8th and x to the 8th, yuck. So this ends up being log base 6 of 27x equals 3. And now I can convert it from logarithmic form to exponential form. 6 to the 3rd equals 27x. And then just go through and solve this the way we've been solving these problems. Get x equals 8. But again, don't forget, check your answers. Take this value of 8, stick it up here. If x is 8, we need to make sure that we get a number up here that is positive and is not 0. So I think we're good. Okay, let's try one more in this section, and that's this one. And again, I notice I have a logarithm, so I think I'm going to switch to exponential notation, but now is not the time. I want to get my logarithm isolated. So first I get rid of that 6. Subtract 6 from both sides. Now again, we have this 3. You can either move the 3 up here and use exponential notation, or we can just divide both sides by 3. I'm going to opt for division because I think it's just going to keep things a little nicer. And that gives us the natural log of x equals negative 1. Now, remember that natural log is really log base e. Now we can switch from logarithmic to exponential notation and get e to the negative 1 equals x. Coming over here, I can use my calculator. E to the negative 1st, and that gives me 0.36787 blah 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 blah, and that rounds to about 0.368. Those problems weren't bad, and I really want to emphasize that in each of these 2 scenarios, before we made the big switch from logarithmic to exponential form, in both cases, before we went from a logarithm to an exponent, we had to get the logarithm all by itself. And now the last batch. Now we've got some fun problems. Oh man, look at these. Let's dive in with problem number 1. So I noticed that I've got log base 8, log base 8. So let me unify this into a single logarithm expression. Of course, every time I add separate logarithms, that's the product property. So I have to take this x plus 30, and I have to multiply it by x, and that's exactly what I did here. Now, notice you might be tempted to use a duh, but this is no duh, because it's not log base 8 equals log base 8. So you could try to make it a duh. You could come over here and say, well, can I write 2 as log base 8 of something? Or you could simply rewrite it from logarithmic form to exponential form. 8's the base, 2's the exponent. That equals my number inside. Ooh, a quadratic. Well, that means we got to get everything over to one side, and we got to factor this thing. So let's spend a little time factoring there. Oh, And that gives us x equals negative 32 or 2. And that was a pretty interesting problem because up here, again, we had a choice. We could force a duh by finding out how we could rewrite 2 as log base 8 of something, or we could just switch to exponential notation. What's this guy over here doing? What is this guy? Did we forget to check our answers? If we put a negative 32 back up here for x, we get a log of a negative. You can't do that. So it turns out, through no fault of our own, we got a bad root, a false root. This is the only answer. Oh my gosh, I'm so glad we remembered to check our answers. Okay, let's do one last problem. That's this one here. Okay, so, whoops, looks like I left the log base out. Oh, no, I didn't. This is the common log. It's log base 10. And again, the first thing I want to do is I want to unify these logarithms using the product property, which means I'm going to take this times that. Well, now again, here's what I can do. I could force a duh by rewriting 3 as the common log of some number. Or I could convert from logarithmic form to exponential form. No one way is better than another. You just have to use what works for you. Looks like I've got some factoring to do, so I'm going to take everything over to one side. Oh, this looks like a beast to factor. Actually, look. What if I divide both sides by 25? I think I can kind of tame this trinomial. And when I do that, yeah, look at how small these numbers get. It's a great factoring trick to see if you can divide both sides by a common factor there. So this actually is pretty easy to factor. And we end up getting x is equal to 8 or negative 5. Again, you know, we see a lot of algebra show up in this. Wait, what? I feel like you're trying to tell me something. Are you trying to remind me that I didn't check my answers? Let's check 8. If I put 8 back up here, that's okay and that's okay. Let's check negative 5. If I put a negative 5 back, oh, no. You got to throw out that negative 5. It was a false root. Wow, I'm glad you caught that. So, tonight you've got some homework. Let's not forget to check our answers in that